Hello, my name is Yash Agarwal. I am pursuing Masters in Data Analytics from National College of Ireland. In this video, I am going to present my research in computing research proposal. The agenda of this presentation is an introduction to research title, research question which I aim to acknowledge through my research, review of past research and proposed methodology. The research title is Denoising Low-Dose Chest CT Medical Image for Improved Lesion Detection Process using Generative Adversarial Network. Analyzing CT image is a manual intense job and requires undivided attention while analyzing them and is prone to human error. Radiology emerged out to be a crucial application area of machine learning. Radiology depends on machine learning techniques like X-ray, MRI, PET, etc., which exposes to high intensity radiation. Reducing the milliampere second attribute is an alternative to reduce the intensity levels. However, there is a trade-off between dose of CT and quality image. Noise reducing without sacrificing actual details like edges and corners is a challenging task which I propose to answer through my research. The proposed research aims to acknowledge the question about the credibility of GANs over other traditional algorithms for denoising and lesion detection. The first research question would be, can generative adversarial networks effectively acknowledge the inherent concerns of low-dose CT image, that is their noise, and productively denoise the image without sacrificing the actual details, that are edges and corners? Second one would be, can GANs augment the lesion detection process and accurately detect lesions for applications in medical science? Previous researchers used deep neural network approach for denoising and lesion detection process, out of which convolutional neural network is used for feature extraction and obtaining high accuracy levels in classification models. However, a drawback of such models is that they are based on supervised learning approach, which could be misleading. Secondly, the applications of GANs in medical imaging can be broadly classified into two approaches. Our first approach is the applications in a generator model, which tries to explore the underlying data structure and achieves new images, while discriminator compares the original and generator achieved image for authenticity. Conditional GANs were engaged in the improvement of super resolving algorithms for low doses at images. Most CNN-based denoising methods, including denoising convolutional neural network, employ mean square error loss for a model optimization, which introduces a blur in high frequency details such as edges. And one more approach, that is a stack generative adversarial network, is used to overcome the issue of traditional techniques, post which one of the transfer learning models such as GrabNet or HNN is used for lesion detection process. Methodology proposed for the aforesaid research efficiently resembles a cross-industry standard process for data mining, that is CRISP-DM approach. The first part is data acquisition. For data acquisition, the annotated data of the chest CT scans are downloaded from deep lesion dataset provided by NIHCC in the format of .png format, with the annotations about the abnormalities as an Excel file. The second part is a CT image denoising methodology. Uh, in this methodology, a low-dose CT image is fed into the generator CNN, which produces a denoised CT image. In the second part, discriminator is pre-trained with routine dose CT image and simultaneously denoised CT is fed into the discriminator part, which differentiates both the images for authenticity. In this, both the network improves with time. The next part is evaluating the image denoising performance. To evaluate the performance of GANs for denoising, low dose chest CT and standard metrics are calculated. The first one is SSIM, which is the structural similarity index measure between low dose image and denoised image. It gives accuracy on the basis of structural information with value ranging from -1 to +1, with +1 values shows better results. Image quality index and peak signal to noise ratio are other metrics. Next part is lesion detection methodology, which is shown here. In this methodology, it utilizes the denoised image with enhanced quality and details like edges and corners as an input to the model, which compares the lesion affected CT image with normal CT images and accurately detect lesions in the chest CT images. To enhance the processing speed of the model, lung field is extracted as the region of interest using thresholding technique. Texture, color, and contour are some of the features which are analyzed on the lesion affected area and are extracted in relevance to color, texture, and shape. There's a need to define a proper loss function for model optimization as it is crucial for the performance of the model. Here I used Adam optimizer with appropriate learning rate, which is utilized for the model optimization. Success of the model is communicated by clearly mentioning the key results of the output. The schedule of the schedule is mentioned here. In According to the schedule, lesion detection part of the research will be a time consuming factor. There are some computational complexities, that is the need of high configuration GPU for the processing image, which cannot be ignored. With this, I come to an end of my proposal. Thank you.